Welcome back, everybody. Today we're going to talk about the distance formula, the midpoint formula, and the slope formula. You may know some of these, you may know all of these, but let's recap what they are. I know you saw them in algebra. I think we saw them earlier this year as well. Distance formula equals the square root of x2 minus x1 squared. Now we're taking the difference of the x's and we're squaring them. So when you square a positive number, it's always going to be positive. When you square a negative number, it's always going to be positive. So it really doesn't matter which order you subtract here, because whether it comes out to be positive or negative, you're squaring it. And then, like, think about 2 squared. 2 times 2 is 4. Think about negative 2 squared. That would be negative 2 times negative 2, also 4. So just find the difference of the x's. We add to that the difference of the y's squared. There you go, and that's the distance formula. We just learned the Pythagorean theorem, and let's compare the Pythagorean theorem to the distance formula. A squared plus b squared is equal to c squared. That's the Pythagorean theorem. Now, if we want to solve for c, we would take the square root of both sides, and on the right side of this, the square root of c squared is just going to be what? Just c. So we would have c equals, or the distance of the hypotenuse equals, the distance of a leg squared, that'd be the horizontal distance, right? Plus the distance of the other leg squared, and we take the square root of both. So this would be the horizontal distance, this would be the vertical difference. We're squaring both of them, we're adding them together, we take the square root of all that. So you can see the Pythagorean theorem and the distance formula are really the same thing. It's the horizontal distance or length squared plus the vertical distance squared, and we take the square root of all that. So it's the same thing, just looks a little different. Midpoint formula. The midpoint is equal to the sum of the x's divided by 2, or we could say the mean of the x coordinates. That's the x coordinate at the midpoint. And then the y coordinate at the midpoint is the sum of the y coordinates divided by 2. The midpoint is a point on the graph. It's called the midpoint. It is a point. So to have a point, you need to have an x coordinate and a y coordinate. So that's the midpoint formula. The slope formula, let me call this MP for midpoint, and here's why. Because the slope, we always use M for slope. M for slope. I've tried looking this up before. I don't think it's exactly known why M is chosen for the slope. There's a few theories out there why it's chosen, but it just is what it is. Slope is always M. Y equals mx plus b. You probably saw that in your math class last year. So it's the difference of the y's over the difference of the x's. Now, are we squaring these here? The answer is no, we're not squaring these. So the order in which we subtract our y's and subtract our x's, that does matter, right? So x2 and y2, those would be an order pair. x1 and y1, those would be an order pair. So the order pairs do have to be in corresponding positions. We can't flip-flop those. So be very careful with the slope formula. Don't mix it up. However, with the distance formula, because we're subtracting and squaring, doesn't matter which order you put the x's in, doesn't matter which order you put the y's in here, but that's not true with the slope formula. Or you might say, anybody know what Greek letter that is? It's a triangle. Delta. Delta y over delta x. Anybody know what delta means in science or in math class? It means change. Change in y over change in x. So the vertical change over the horizontal change, that is how we find the slope. Okay. So I think you've seen all these before, so pause the video now if you're in class, or if you're in class, let's take a moment and work example 1 on your own. Go ahead. Okay, so we have point A, which is -4, -2. We have point B, which is 6, 4. The midpoint is the mean of the x coordinates. Well, that's -4, that is 6. -4 plus 6, that's going to give us 2. We divide that by 2, giving us an x coordinate of 1. Y coordinate, same thing. -2 plus 4, that's going to give you +2 divided by 2. The y coordinate is 1 as well. So the midpoint is at 1, 1. Now, we should always either physically plot it or just mentally plot it. 1, 1's right there. Does that seem like it could be the midpoint? Yes or no? Yeah, that seems like it could be the midpoint. How long did that take us to plot that? Not long, half a second, right? Maybe 2 seconds, whatever. Now, let's say you messed up a sign here and you said that this was -1. So 1, -1, and then you took the time to plot it and you're like, okay, that my midpoint's right there. Something's going on. Either the drawing is way off or you made an error. Most likely you made an error. So if that happens, just check and double check your work. Go back, see if you can find the mistake you made. So just a little bit of extra time allows you to check that work. No big deal. All right, part B here, find the slope of AB. That's going to be the difference of the y's over the difference of the x's. So I said this y, 4, minus this y, -2. Well, 4 minus -2, that's going to become 4 plus 2. We're going to have a numerator of 6. Difference of the x's, 6 minus -4. When you subtract -4, you have to add, so that's 6 plus 4. So we get 10 in the denominator. 6, 10 simplifies to 3/5. Make sure you always simplify the slope. All right, please don't give me an unsimplified slope. Remember rise over run? That was a thing last year, rise over run. So this is the vertical change. We're rising 3. This is the horizontal change. We are running 5. And also remember, if we worked it the other way, you would have gotten -3 over -5, which is the same thing as +3 over +5, or +3/5. So just make sure you always write it as a simplified fraction. If it's supposed to be, like if it's a negative over a negative, make sure you write it as a positive. But there you go. Questions on that? Finally, the length of AB. This is the distance formula. Distance formula is the difference of the x's. Well, 6 minus -4. That's going to be 6 plus 4. So that's 10. 10 squared is 100. Plus 4 minus -2. That's going to be 4 plus 2, which is 6. 6 squared is 36. Square root of all that, that's the square root of 136. Now, 136, this is 4 and 34. 4 and 34. 34 is not prime, but it's 17 and 2. 17 and 2. So, square root of 4 is 2, and we're left with 34 underneath. So, 2 root 34. Now, we just learned about the Pythagorean theorem, so an alternative method for this would be to form a right triangle. You don't have to do this, but it's good to know that it's a tool you can use. So we'll form a right triangle here with the horizontal change and the vertical change. So let's see here. This is going to be the point 6, -2. So to go from -4 to 6, perfectly horizontal, that's a length of 10. And then to go from -2 to 4, that's perfectly vertical. That'd be a length of 6. So you can see we have a right triangle that has legs of 6 and 10. You could use the Pythagorean theorem there if you wanted to find the length of AB. It'd be the same thing. Questions on that? Let's talk about Pythagorean inequality theorem. The Pythagorean theorem, we learned about that last class. A squared plus B squared is equal to C squared. So if this is true for a triangle, then that's a right triangle. The Pythagorean theorem only holds true in a right triangle. Now what if we had a squared plus b squared and that was less than c squared? So think about that think about that triangle. It's not a right triangle because and when we say c, we mean like c is the longest side. So let's make a note of that. So we'll say C is the longest side. C is the longest side in this situation because it's not the hypotenuse here because it can't be the hypotenuse if it's not a right triangle. So think about this, if this would be an acute triangle or an obtuse triangle and why. Okay, so in this situation we're saying that C is longer relative to the other two sides. So if you were to draw this out, here's a right triangle where C is the longest side. And if I want C to be longer, it looks like this. Your longest side is longer relative to the right triangle. It's an obtuse triangle. So that's going to be obtuse. Obtuse. And then we'll also look at it this way. A squared plus B squared is greater than C squared. So now what we're saying is the longest side, C, relative to the two shorter sides. Well, it's not as long as compared to a right triangle. So as compared to a right triangle in this situation, the longest side is not as long. So that's going to be an acute triangle. So that's the Pythagorean inequalities theorem. Questions on that? All right. I think you guys have enough knowledge to tackle example 2. So if you're in class right now, work it. And if you're watching the video, pause the video and tackle example 2. Good luck. All right, so on example 2, we find the length of each side of this triangle, NE square root of 53. Can't simplify that. EW square root of 40. We could simplify that, but we're not going to. You'll see why in a second. NW is the square root of 89. So here's my supporting work for that. So if you need that, there it is. Okay. So now that we have that, what's going to be C here? NE, EW, or NW? NW is going to be C. It's the longest side, right? C is NW. So it's going to be leg squared. That's the square root of 53 squared plus, I shouldn't say leg because it might not be a right triangle, right? So shorter side squared plus the other shorter side squared. How does that relate to the longest side? C squared. Here is why I did not simplify this square root. I knew I was going to be squaring it. I knew I was going to be squaring all three of these. Watch how easy it is to square them when it's an unsimplified radical. You get 53 plus 40. How does that relate to 89? Well, 53 plus 40, that's 93. 93 is greater than 89. So what that means is this is what? That's an acute triangle. If the two shorter sides squared are greater than the longest side squared, that's going to be an acute triangle. The longest side relative to the two shorter sides is longer. Back up. I think I said that wrong. The longest side relative to the two shorter sides is not as long as compared to a right triangle where it is equal, right? Okay, so there you go. That's an acute triangle there. If you were asked to find the side lengths and not round it, you would tell me it's square root of 53, square root of 89, and then let's see here, that would be what, 2 root 10, I think, 2 root 10 for this one. So you would need to simplify it if I asked for the side lengths, but if it's just whether it's acute, obtuse, or right, this is how it would be done. Example 3. Quadrilateral ABC has vertices of A, negative 3, 4, B, 6, 1, C, 4, negative 5, and D, negative 5, negative 2. Find the length of each side of ABCD. Then part B, find the length of the diagonals of ABCD. And then part C, give the most descriptive name for ABCD and explain. So give that one a shot, everybody. Pause the video now. So here are the 4 side links. If you missed any of these, go back and try to find the error that you made. So if that was you, pause the video now. Try to find the error. If not, let's keep going on. Alright, so we apply the distance formula to the diagonals. Now remember, the order in which these are written matters, right? A is adjacent to B, B is adjacent to C, C is adjacent to D, and D is adjacent to A. What that means is A, C are not adjacent. B and D are not adjacent as well. So AC is one diagonal, DB is the other diagonal. Here's the supporting work for that. We're just applying the distance formula. We get the square root of 130 on those. Looking at 130, you know, I can't look at that and know, like, right off the top of my head what the perfect square factors are, if there are any. So I made a factor tree here. 130 is 2 and 65. 65 is 5 and 13. So we have the prime factorization is 2 times 5 times 13. There's no pairs here, so I can't pull anything out of the square root of 130. So what's the most descriptive name here? We've got, first off, opposite sides are congruent, like these two blue ones, they're congruent, these two red ones, they're congruent. So what does that make it? Hang on, just off A. Just off A, what do we know? It's a parallelogram, right? So we have a parallelogram. Is it a rhombus? No. If it were a rhombus, all four of these sides would be congruent, right? So if it's not a rhombus, it's also not a square, because every square is a rhombus, right? So we know it's not a rhombus. We know it's not a square. Definitely a parallelogram. The question is it a rectangle? Well, the diagonals are congruent, which means it has to be a rectangle. In a rectangle, the diagonals are congruent. So there you go, rectangle. Very good. Questions on that? Okay. All right, folks at home, thanks for watching, or folks in the class. Class I'm not in right now. Thanks for watching. Like and subscribe. Leave a comment down below.